This video is to show you how to graph logarithmic functions. As you can see, I've already given us a reasonably straightforward logarithmic function of y equals log base 2 of x. Same as any other function when we go to graph it, something we can always do is build an xy table for it. And that's what we're going to do here as well. We're going to use an xy table to graph this out. Now, the thing with logarithms though is we could just take this function and do an xy table like we have done in the past, which is just pick random x values, plug them in, see what you get for y. But it is a little bit more complicated with this function because, first off, as we've discussed in our earlier logarithm videos, you may not have a calculator that will let you plug in the log base 2 of something. If you have a pretty simplistic calculator, it may only allow you to do log base 10. Which you could do change of base and all that sort of thing to still make it work either way. Even if you have a calculator that can handle log base 2, it's still going to be hard to pick numbers that will really work. Right? I mean, if you're just picking random x values to plug into this, you're going to get a lot of nasty decimals on there. What I would recommend instead for graphing a logarithmic function is let's change it from log form into exponential form. Remember, the way that works is bases stay bases, so this is a base of 2. And then the way I say it is whatever is by itself in one form on its own side of the equation gets to be with the base in the other form. Meaning, since y is by itself in our log form, it would be the exponent with the base of 2 in exponential form, leaving it to be equal to x. So we've created an equation here of 2 to the y power equals x. And then, rather than look at this as an xy table the way we normally do, where we plug in random x's to get y's, what I think would be easiest is if we pick random y values and solve them out to see what we get for x. Right? That's rare. Usually we don't do xy tables that way, but there isn't anything in the rules of xy tables that says we can't. The whole point of an xy table is you're picking number for one variable and then using it to solve for the other. It doesn't matter whether it's x to y or y to x. So, for example, say we plugged in 0 for y. Well, that means if we plug that into our equation, it'd be 2 to the 0 power, and 2 to the 0 power is 1. So 1, 0 would be a coordinate point. And we could plug in positive 1 for y. So we'd be taking 2 to the first power. Well, 2 to the first power is 2, so we would get 2 for x, making 2, 1 a coordinate point. We could plug in positive 2, which means we'd be taking 2 to the second power, 2 squared, which gives us 4 for x. So 4, 2 would be a point. We could also look to plug in some negative numbers. So say we plugged in negative 1 for y. Well, that means you're taking 2 to the negative first. If you'll remember from some of these previous videos in this chapter, in this section, we've talked about whenever you are taking, whenever you're dealing with a negative exponent, that gives you reciprocals. So 2 to the negative first should be the reciprocal of 2 to the positive first, meaning instead of 2, we would get 1 over 2, 1/2. So 1/2 negative 1 would be roughly right about there. And we'll plug in a second negative number just to round this out. So we'll say we plug in a negative 2. Well, 2 to the positive second power gave us 4. So 2 to the negative second power would give us 1 over 4. Which we're going to have to estimate a little bit here, but it'd be pretty close to there. And so what we see here is that a logarithmic function is a curve that looks something like this. It's not quite perfect. It's really going to hit more in this area, I think. So something more like that. And then it curves here, and it starts to flatten out, as it looks like if you look at this on a graphing calculator, it will look like it touches the x-axis. But the reality is, if you zoom in, you'll see that it's going to be getting closer and closer, but it's always a little bit away. In other words, if you've already watched our graphing exponential functions video, which you probably should have before watching this one, remember that logarithms are the inverse of exponentials, meaning just the same way the exponential function had a vertical or horizontal asymptote, at y equals 0, with the logarithmic function here, we have a vertical asymptote at x equals 0. And if you'll remember, the domain for our exponential function was negative infinity to positive infinity. Well, if you look at the range for our logarithmic function here, our range is negative infinity to positive infinity, meaning it goes down forever and up forever. The range for exponential was from 0 to infinity because it couldn't go below the x-axis. And well, that's going to be our domain for this logarithm because you'll see it can't go past the y-axis. So our domain is 0 to infinity. Meaning, remember when we've talked about inverse functions in general, it basically boils down to x's and y's switch. The domain becomes your range, range becomes your domain, x's become y's, y's become your x's. So, if exponentials and logarithms are inverses of each other, pretty much everything is just flipping. That includes the coordinate points on our xy table. If you were to take this whole xy table right here and compare this to the xy table from our graphing exponential functions video, you would see that each of these coordinate pairs is just flipped from what we got with our 2 to the x function. Anyways, that is how I would recommend graphing logarithmic functions, is rather than try and do an xy table from the log form, I would just change them to exponential form. Even if you have some extra stuff, I would still do that. So, like, for example, let's say you had y equals the log base 2 of x plus 1, no parentheses. What I would do is I would subtract that 1 over here, giving you y minus 1 equals log base 2 of x, and then I would change that to exponential form, giving me a 2 to the y minus 1 power equals x. And then you're still pretty safe to pick any integer y value, and it still shouldn't cause you too much work to be able to solve that out. And, if it is x plus 1 in parentheses, like if you had something like that, well, then just keep those together, right? Make it 2 to the y power equals x plus 1. And then you're basically doing the exact same xy table we just did, except every x value has a 1 added to it, right? I mean, even if there are extra things added on, like transformations added on, there should still be ways that you can change it to exponential form in such a fashion that I still think it'd be easier than graphing it from the log form itself.